All right, welcome back, Hononegah Geometry. Today we're going to start Chapter 4 on 4.1 Translation. We're moving things around. So translations, transformations, we're going to go through this chapter. We're basically moving pictures, and here we go. If a point 3, -6 was moved 5 units to the right. So think about this. If I have a point, here's +3, -6, and I move it to the right by 5 units, what would that point then be? Well, if I move it 5 to the right, it would be the point 8, -6. The next one, you have the same point, but now we're going to move it up 2. So I'm just using the same little picture here. I'm going up 2. That would be the point 3, -4. And so that is truly a transformation, moving things around. I got one more here in the warm-up section. In which quadrant is -4, 2? Well, going around, it's quadrant 1, quadrant 2, quadrant 3, quadrant 4. So -4, +2, okay, would be in the second quadrant. All right, so we're going to talk about translations. And translations is when you take a figure and it's a rigid motion. We'll get into that just a little bit, but you're just moving it. It doesn't change the figure at all. You're just moving the figure from one point to another. And so the first way we're going to talk about this is called a vector. A vector is a quantity that has both direction and magnitude, or size. A vector is represented in the coordinate plane by an arrow drawn from one point to the other. So a vector starts at one spot and goes to the other. Okay, so it has magnitude and direction. The diagram shows a vector with the initial point or a starting point of the vector P and the terminal point at Q. So it goes from P to Q, and it looks like a ray. Okay? It looks like a ray. So P to Q. A horizontal component. So notice that it's 5 units to the right. A +5, +5, and 3 units up, which is a +3. So in component form, you would write that this way. So it goes 5, 3. The first one would be the X, and notice it's positive because it's going to the right. So negative would be going to the left. And this is the Y. The positive would be up, and the negative would be down. So here we go. Write the name and the vector. So B to C. So it looks like a ray. And in component form, this is going 9 units to the right. So 9. And it's going down 2. Next one, we're going from S to T. 1, 2, 3, 4, 5, 6, 7, 8 units to the left, and it's not going up or down, so therefore it's a 0. So this is component form for vectors. Now, a transformation and a translation. A transformation is a function that moves or changes the figure in some way to produce a new figure, called an image. Another name for the original is called the pre-image. The points on the pre-image are the inputs for the transformation, and the points on the image are the outputs. Now, a translation is merely a slide. It's just changing it up, down, left, or right. The image is the figure that is created as a result of the transformation. And the pre-image, I'm going to write that in here, is the original. A translation moves every point of the figure in the same direction. More specifically, a translation maps or moves the points P and Q of the plane. In vector, it's A and B. The new points, if you're moving an entire figure, the new points, you use a little tick mark. So if we start off with P, and we're going to P prime. We're starting off with Q, and we're going to Q prime. Translation maps lines to parallel lines and segments to parallel segments. For instance, PQ is parallel with P prime, Q prime. So when you are mapping more than one point, everything would be parallel. The vertices of the triangle A, B, and C. All right, let's start with that. So A is the point 0, 3. B is the point 2, 4. and C is the point 1, 0. Now, it's asking me to do a vector, translate triangle ABC using the vector positive 5, negative 1. So if I go 5 units to the right and down 1 unit, and that's C prime then. That would be A prime, B prime. And so my new figure, which has been translated 5 units to the right and 1 unit down. Notice this is a rigid, meaning none of the actual triangle itself has not changed. It is the same figure, it has just been slid 5 units to the right, or translated 5 units to the right and 1 unit down. You can also do, instead of using a vector form, you can also use a different type of notation. This is saying the same thing. XY to X plus A and Y plus B. So it's telling you how far you're moving X and how far you're moving Y. So this is just another way of asking you to do the same thing. So here we go. Graph the quadrilateral A, B, C, D. I'm going to move down here a little bit so I have some space. So A is -1, +2. B, -1, +5. C, +4, +6. And D, +4, +2. So here's the quadrilateral A, B, C, D. Now, translate using the rule. X plus 3 and Y minus 1. Note it with the prime notation. So as we do each one of these. So +3, I'm going to change colors. +3, -1. There's A prime. D prime. C prime. B prime. Notice it's a rigid, okay? It hasn't changed its shape. It's merely to the right 3 and down 1. The image xy, x plus 4, y minus 7 is PQ with endpoints of -3, 4 and 2, 1. Now this one's a little backwards. They're telling you the ending for P and Q. Find the coordinates of the endpoints of the pre-image. Like, where did it start? So remember, it went +4 and -7. So now, I'm going to pick a different color here. I need to go backwards 4. It goes off the picture here. And then here's the original Q and the original P. So if I went to the left 4, it would be -7. If I went up, it would be 11. So the original P is at -7, +11, and the original Q would be at -2, +8. So again, I'm just doing everything backwards. So here's the original Q, while this would be, oops, I missed it, the image for PQ. Asymmetry is the transformation that prefers length and measure, also known as a congruence transformation or rigid motion. And I've said this one a couple of times. Basically what I'm saying is, if you're moving it and not changing the actual length or the angle measure, you are going to have a rigid motion. You're just changing the location of the picture. Translations would be considered a rigid motion. Write the rule for the translation for ABC. Now, they're asking me to write a rule, and they're not telling me whether they want it in component form or as a notation. So I'm going to do both. Then verify the transformation. 1, 2, 3, 4. It's going positive it's going -4 for A and up 1. You can also write this as x minus 4 and y plus 1. So again, both of these are technically correct. One is in component form, the other one is in notation form. And then to verify the transformation, did all A, B, and C all make the same -4 plus 1? -4 plus 1? And the answer to that question is yes, each one did. When two or more translations are combined to form a single transformation, this is called composition of transformations. Okay? The theorem above is important because it states no matter how many rigid motions you perform, the length and angle measures would still be preserved. So they're asking me to do two translations here. I'm not going to do both. I'm going to combine them into one. So if I add 5 the first time, subtract 1 the second time, I'm really only adding 1. And if I subtract 2 the first time and subtract 2 again, I'm actually subtracting 4. So I'm going to combine these two translations into one. And so R is at -8, +5. S is at -6. -8. Here's R, and here's S. So now, you can combine them, or you can do them one at a time. And so I'm going to do one at a time first. So if I added 5 and subtracted 2. So here's S prime, R prime. And the next one, you're subtracting 4. And subtracting 2 again. Technically, this would be R double prime and S double prime because you moved it twice. Notice, it's all rigid motion, meaning they're all the same picture. I just moved it around. Now, if I just went straight to here, and again, I'm going to pick a different, if I just went +1 and down 4, notice I will end with the ending R double prime. So the fact that I went straight from the beginning to the end and I combined the two. The boat heads out to the point A on an island towards point D. The boat encounters a storm at B and goes 12 miles east and 4 miles north of its original point. The storm pushes the boat off course to point C as shown. Write a component form for vector A to B. So from A to B, it went +12, +4. So that's the answer to the first one. Write a component form from B to C. +4, -2. Write a component form for the vector that describes a straight line from the current position C to the intended position D. So what would I need to do to go from there to there? I would need to go +2 and +3 to get from C to D. Line T in an xy plane is the slope of -1/3 and passes through the point 910, which is the equation is true. Now, formula that we've learned in this class and you learned in Algebra 1. Y minus the y of the point equals slope, x minus the x of the point. Distribute the slope. Y equals -1/3 x. I'm going to add 10. I'm going to add 10 and get 13. So the answer to this question is D. Your homework assignment is a worksheet. If you have any questions, make sure you talk to your teacher, and good luck.